Alright, so in this video, I'm going to solve the equation x to the power of 12 minus 1 is equal to 0. So to solve this, I'm going to first rewrite this as x to the power of 6 to the power of 2 minus 1 squared is equal to 0. And the reason I'm doing this is so I can use the property a squared minus b squared is equal to a plus b times a minus b. So this turns into x to the power of 6 plus 1 times x to the power of 6 minus 1 is equal to 0. So this gives me two equations. I get x to the power of 6 plus 1 equals 0, and x to the power of 6 minus 1 equals 0. Now I'm going to do the same thing again. I'm going to rewrite x to the power of 6 minus 1 equals 0 as x to the power of 3 to the power of 2 minus 1 squared is equal to 0. So I can use this property again and get x to the power of 3 plus 1 times x to the power of 3 minus 1 is equal to 0. Now, for x to the power of 3 minus 1 equals 0, I'm going to rewrite this as x to the power of 3 minus 1 to the power of 3 equals 0, so I can use the property a to the power of 3 minus b to the power of 3 is equal to a minus b times a squared plus ab plus b squared. So this turns into a minus b times a squared plus a plus 1 is equal to 0. Sorry, this turns into x minus 1 times x squared plus x plus 1 is equal to 0, which gives me yet another two equations. So now I have x minus 1 equals 0 and x squared plus x plus 1 equals 0. So for x minus 1 equals 0, all I have to do is add 1 on both sides, and I get x is equal to 1. And for x squared plus x plus 1 equals 0, I can use the quadratic formula. So by using it, I get x is equal to negative 1 plus or minus the square root of 3i over 2. So these are two more solutions. And now we aren't done yet because we also have to solve these. So now I have x to the power of 3 plus 1 is equal to 0. And I'm going to subtract 1 on both sides, so I get x to the power of 3 is equal to negative 1, meaning x is also equal to negative 1. So this is another solution. Now for x to the power of 6 plus 1 equals 0, I'm going to again subtract 1 on both sides. So I get x to the power of 6 is equal to negative 1. And if I take the 6th root, I get x is equal to 6th root of negative 1, which is equal to negative 1 to the power of 1 over 6. So now, the 6th root of negative 1 is, we know that I is equal to the square root of negative 1, which is equal to negative 1 to the power of 1/2. So negative 1 to the power of 1 over 6 is the same thing as negative 1 to the power of 1/2 minus something. So now 1 over 6, or I should say 1/2 minus 1 over 6 is equal to 1 over 3. So 1 over 6 plus 1 over 3 is equal to 1/2. We know this. Meaning we have negative 1 to the power of 1 over 6 and this plus, or sorry, 1 over 2 minus 1 over 3 is what we can rewrite 1 over 6 as. Now, this is the same thing as 1/2 plus negative 1 over 3. And if I have something in the form a to the power of m plus n, This is equal to a to the power of m times a to the power of n. So this is going to equal negative 1 to the power of 1/2 times negative 1 to the power of negative 1 over 3. Negative 1 to the power of 1/2 is the square root of negative 1, which is equal to I. So we get I times negative 1 to the power of negative 1 over 3, which is the same thing as 1 over negative 1 to the power of 1 over 3, which is equal to negative 1. So I get I times negative 1, which is equal to negative I, which is my final solution. Alright, so in this video, I'm going to solve the equation 9 to the power of x is equal to 36. So, to solve this equation, I'm going to first start by taking the log on both sides. So I get log of 9 to the power of x is equal to log of 36. Now, if I have something in the form log a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I have log 9 to the power of x, and I can move x to the front, so I get x times log 9 is equal to log 36. And from here, I can divide both sides by log 9. So these two cancel out, and I get x is equal to log 36 over log 9. Now, I'm going to rewrite log 36 as log of 9 times 4. So I did this because I can use the property log of a times b is equal to log a plus log b. In this case, this turns into log 9 plus log 4, and I have this over log 9. So now this is equal to log 9 over log 9 plus log 4 over log 9, which is equal to 1 plus log of 2 squared over log of 3 squared. And if I have something in the form log of a to the power of b, I can move this exponent b to the front, so this turns into b times log a. In this case, I can move 2 to the front over here, 2 to the front over here. So I get x is equal to 1 plus 2 times log 2 over 2 times log 3. From here I can cancel out these two 2's. So I get x equals 1 plus log 2 over log 3. Now log 2 is equal to 0.3010, and log 3 is equal to 0.4771. So if I divide these two, I get x equals 1 plus 0.6309, meaning x is equal to 1.6309. So this is my answer.